Okay, advanced system design, week 3, part 2. We're trying to talk about the type of heat flow. How do we control this flow and how do we move and transport heat energy from one place to another? And again, a lot of people made a lot of businesses and inventions based on that. This is how the pump can play, steam, and evolution of a lot of way to heat a house in a sophisticated way. We'll talk about that. So heat transport, you want to transport heat from one place to another. You don't want to have combustion inside your house. You want to be as far as possible. We're burning oil and gas. It's not like we're burning nice clean wood that smells nice, right? You don't want to burn oil in your house. You want it as far as possible. What actually you want is the heat. If you smell gas, probably you'll be alarmed. You don't want that. So we can transport heat from where we make it to the house. Unlike a fireplace where you can just throw pieces of wood and you get the heat right away. We'll talk about comfort, our human comfort. What temperature you need to be comfortable in your own house, and what constitutes comfort. Okay, so the climate. What is the difference between climate and weather?
Climate is weather over a period of time.
Excellent. So climate is over a long period of time, weather is short burst. Temperature around us, humidity as a factor of comfort, energy for home use, and combustion heating. I think all of us now use combustion for heating, which means we're burning stuff to get heat. Electric resistance heating, that's a space heater. Again, they are very, very efficient, but very, very expensive. We'll see that. And we'll talk about the refrigeration cycle, which is, in layman term, heat pump. We pump heat from cold to hot, or hot to cold, whatever you want. Yeah.
The kerosene heaters are pretty good too.
Yeah, but they're not supposed to be indoors.
Kerosene heaters?
Yeah.
They're not supposed to be indoors.
Yeah. It's against the law. Yes, so no, yeah.
Which aren't those?
Huh?
Which aren't those? Wow.
You feel like you get a kerosene like they do actually combustion. They
Yeah.
burn and they make heat.
Yeah.
Yeah, but I've seen it actually in houses, in closed places. You're not supposed to do that. See somebody opening a window and telling people, say, don't do that. Yeah. Anyways, I went to a boxing gym in Chicopee, Hollywood, boxing gym, and it was a huge gym, and they had 2 propane heaters, salamanders, running. I'm not working out here with these things on. They tried to kill me here. It's not good for me. I didn't tell them.
Oh, yes.
Okay, so we did say heat with energy transport from high to low, and so heat is energy. I'm trying to transform energy from one place to another, and energy always goes from high to low. We agree on that, right? The billiard ball, what does that have to do with anything? So when you hit pool ball, it has an energy. Don't you notice once it hit the other ball, sometimes it stops? Depending on the top spin, so usually it stops, the energy goes to the other balls. So the same thing happens with molecules. Molecule with high energy will hit another molecule and energize it. So in a molecular level, the same thing happens. You heat something, it vibrates, the electrons vibrate so much they have more energy. Once they touch another molecule, they will transfer that energy. Guys. So molecules do the same thing. If I heat this table from the one corner, eventually it will start to spread heat. Why? Because the molecules will transfer heat to each other. Same way, yeah.
Can you just re-clarify the billiard balls example again?
Yeah. So molecules, once they have a lot of energy and they hit another molecule, they will transfer some of that energy. So when you hit a ball, playing ball, the ball will have a lot of kinetic energy. Once it hits the other ball, usually it stops, and the other one ball or 2 balls give the energy. Transfer. So the same thing happens with molecules. And I'm using the billiard ball because we're talking about fluids, like a molecule of water, a molecule of gas, which also have the same thing. They're loose, but they will hit each other at some point. And the more you heat gas or water, the more energy, and the more it will start moving, and eventually they will hit each other and transfer that energy. So energy will transfer from molecule to another. So right off the bat, if I say, what do you think will transfer heat faster? Solid, gas, or liquid?
Probably gas.
Faster.
Solid.
Solid. Because the molecules are stuck to each other. Right? They're next to each other and they're packed. Look, it's one piece. It's gonna transfer to each other.
Oh, okay.
Next, what's gonna be faster? Liquid, which is water. Then gas. It transfer slower because they're more, the molecules are more very far apart from each other. Okay? I think that's enough. Yeah,
Is
question?
that why they say don't pack the walls with insulation? Because
Yeah, that's a good analogy because I did say like at some point if we go to infinity and make this very solid, you are actually not
Hurting you.
yeah. When you pack your wall with insulation, what you're doing, you are counting on those little small cavities. When you pack it up, you are actually changing the material,
Making it
insulation.
easier.
Yeah.
Yeah.
We want those air pockets.
I got you.
Okay.
No, you want those
why
air
do
pockets.
they blow that hard insulation in so strong and tough into the walls?
It depends into the material. Some material needs to be packed, some material don't.
Fluffy,
Yeah.
If you
fluffy
look-
paper shit.
If you look at this under the microscope, you'll see there's a lot of bubbles.
Pores.
Yeah, it's there's a lot of bubbles, and those bubbles are air pockets, and those air pockets are actually insulation. So if you buy one of those Gore-Tex jackets, they have air pockets in it, and some of them sometimes have inert gas. And we'll talk about that. How do we do insulation? Okay, thank you.